Hello, welcome to everybody to this new session of As of 2020. Now we are talking about climate change, to global, to local, to global risks and responses. And we are focusing on this big problem with big scientists, the key figures of the new sixth assessment report of IPCC that is ongoing in these years. And so we have the unique opportunity to go into the kitchen to see how scientists are refining their instruments and producing their evidence to support policy making and responses to these impacts of climate changes in the next years, in the years to come. So these people are four persons. We have with us in Trieste Filippo Giorgi of the ICPT, and he's an important climatologist and modelist. He has worked for all the previous reports of IPCC, and at least in virtually, we have other three key players in the current report of IPCC, such as Valérie Masson-Delmotte, that is the co-chair of the first working group of IPCC, the working group focused on basic science, the science, physical science of climate change. And then Hans-Otto Pörtner, that is the co-chair of the second working group on risks, on vulnerability, on impacts of climate change and adaptation. And finally, James Ferguson Skea, that is the co-chairs of the third hello to everybody, working group focused on solutions, on mitigation and so on. So I think we have a very important opportunity to discuss with them. So please make some, also feel free to, also in remote, to ask questions to these experts, because we have the opportunity to go in deep in the current report of the sixth assessment report of the IPCC, and to understand better which are the new evidence, the new results in every field of this very complex matter. So I want to start giving immediately the floor to Filippo Giorgi, who has a very original argument, putting in a very suggesting parallelism between climate change and our current pandemic, COVID pandemic. So I will leave the floor to him now for his presentation. And then we will go on with the other speakers.
Okay, thank you, Luca. Thanks to everyone. The title of my talk, it's an introductory talk. I think the next speakers will give more technical details, so I thought I wouldn't give a really technical talk. But during the lockdown, like all of us, I had a lot of time to think, maybe too much time to think, but I had some reflections on some similarities between what has happened in the COVID pandemic and what is happening in terms of global climate and other environmental crises. And I really wondered to myself why we don't call climate change and other environmental problems a global environmental pandemic, because based on what I will show, I think we probably should, and of course we should also treat it as such. This first slide you see on the right. Okay, on the right you see the increase in carbon dioxide concentration. I'm sure many of you have seen this slide. And on the left, the increase in temperature, global temperature. In the last 100 years, global temperatures have increased by slightly over 1 degree, and carbon dioxide concentrations by more than 45%. And what you see from these trends, you see that these are, I would say, almost exponential trends. Definitely they are higher than linear trends. This is what we were seeing at the beginning of the COVID crisis. When I saw the first plots of the number of COVID infections, they really looked very similar to what's happening today to carbon dioxide, which is the main driver of global warming, and global temperatures themselves. But there is something else that is showing a exponential behavior, and this is the number of extreme events. One of the things we are pretty sure about, and I think Valérie will maybe mention this, is that global warming will lead to more extreme events. A warmer atmosphere has more energy and can contain more water vapor, so when it rains, it tends to rain very hard. We have experienced this in the last week. You remember what happened in Verona, in Venice, actually not once but twice in a week in August. And I remember talking to a friend of mine who lives there and said, oh, but this never happened before. Now we're getting all these floods in August, which is a really dry month in Italy. What you see here, these are data from the Munich reinsurance company that show the number of what they call catastrophic events of meteoclimatic nature. So these are floods, droughts, forest fires, or whatever. And these are catastrophic in the sense that they produce a lot of damage and they kill people, okay? And you can see that in the early 80s, we had about 200 of such events per year. And in 2018, we had about 800. I don't have the number for 2019, but 2019 was a super extreme year, so I think we will have numbers even higher. But 800 compared to 200 is an increase of a factor of 4. An increase of a factor of 4 in 40 years means a doubling time every 20 years. This is, in terms of climatological timescales, a very, very fast increase in these types of events. Very similar to what was happening to the COVID crisis at the very beginning when we saw all these curves, you know, number of cases is doubling every 5 days or 7 days or so on. The same is happening in terms of our climate. Another issue with COVID was the global aspect of this crisis. What you see here is a figure from the last IPCC report, Working Group 2 in 2014. You don't need to see all the symbols. The symbols are just sort of characterizing the different types of impacts of climate change in different sectors, like agriculture or water or whatever. But the key thing here is the same that you see if you see a map of COVID infections. You see that the whole globe is covered by these symbols. We are really looking at a global crisis, same as the COVID crisis, and still we do not call this a pandemic, which to me is actually kind of strange. I don't know if the next report will have a similar picture, but probably will be much more dense than it is now. Something else that is similar between the COVID crisis and the climate change crisis is the occurrence of threshold tipping points. These are thresholds. If you pass this threshold, you cannot stop this process anymore. It's the same that happens in a focolaio, we say in Italian. I'm not sure what the English word is. You know, if it becomes too big, then it keeps going. It's very, very difficult to stop it. There are different tipping points. I think maybe one of the speakers will talk about this later, but the collapse of the thermohaline oceanic circulation or the melting of the Greenland ice sheet. And there was an article just came out, I think last week, where some scientists actually think that we have passed this tipping point. And if the temperatures stay the way they are now, the whole Greenland ice sheet might actually melt, of course, in centuries, not in decades, but this will be a huge, huge modification of the global climate. 7 meters of sea level rise, you can imagine what this means even for, actually this building may actually disappear. So all these things that are in common between the COVID and climate change, there is also other environmental crises. One is air pollution. There was an article in 2018 by Jos Lilleveld and collaborators, and they did some epidemiological studies that showed how air pollution every year kills 4 to 5.5 million of people. I mean, so far in 8 months, COVID has killed, what, less than 1 million people. Every year, outdoor pollution causes the premature death pretty much in this very similar way as COVID to 4 to 5 million. And yet nobody calls air pollution a global pandemic. And I wanted to show you another sort of interesting, there you go, parallel between what happens to COVID and, well, to the current crisis and the climate crisis. What you see here is a reconstruction from a paper appeared in Science in 2013 of the global temperature. It's actually an anomaly compared to a reference period in the last 11,000 years, a period that we call the Holocene. This is the last interglacial time where our sort of civilization really developed. You can see on the side, this 0.4, 0.8, this means 0.4, 0.8 degrees. So you see that in the last 10,000 years, the global temperatures have been quite stable, okay? They varied very slowly. Climate has been relatively stable. Now they're descending towards the next ice age, which will happen in the next 20, 30,000 years, so we don't need to worry too much about that. So think of this as the temperature of your own body, okay? This is, you're pretty happy because everything is stable. And then in the last 100 years, this is what happened. You see this kink of the curve all the way up. This is in scale from the same paper. This 1 degree, actually is from 2013, so today would be even higher. In 100 years, something that is incredibly fast if you think of climate timescales. If your body temperature did this, they would probably take you directly to the hospital because they would say, and take the tampons, because they would say that this is a sign that your fever is growing too much. But let's see what could happen in the future. There are two important futures concerning climate change. One is the so-called Paris Agreement future. If we can stay within the 2 degrees of global warming, difficult to achieve, but not impossible. This is what would happen if we could stay, this is all in scale, if we could stay within the Paris Agreement. Again, think of this as your own temperature. If this happens to your body, then you start getting really, really, really worried, and everybody will start getting really, really worried. And this is the most optimistic, well, if not the most, one of the most optimistic views we have for our planet. But let's say that we cannot stay with the Paris Agreement, but we follow the so-called business as usual trajectory, then this is what would happen. Okay, I can even go to the next one, just to make it explode. This is what could happen to the Earth's temperatures if we don't do anything to mitigate climate change. If this was your own body, I'm not really sure you think you would survive. And in fact, this is the level of warming that might really become a real threat to society. So you can see there are many parallelisms between the COVID crisis and what's happening to our climate, so that I actually do think that climate change should be called a global environmental pandemic. During the lockdown, I really wondered why we don't call it that, because we have climate is causing more deaths, more disruptions, and yet we don't call it a pandemic. If we called it a pandemic, that we should treat it as such. And there are several things that I think we have learned from the COVID crisis, and I'm almost done, that can be applied to global warming. You see here some of the points. For example, international coordination. These are global crises that have to be faced in a global way. It doesn't help if Italy does something and the US does something totally different. Because, with the COVID, we saw this. Italy got better, but the US now is doing really bad. And India is doing really bad because they had different strategies to deal with the crisis. So it's very important for COVID as well as for climate change that things are done in a coordinated way. It doesn't help if Italy decreases emissions if all the other countries actually don't do this. Immediate action. We had a lockdown, all the countries had a lockdown, I think because there was not an early understanding of the crisis, there was not an immediate action when the first sign of the crisis started. So if we want to avoid a lockdown that might have to last for several years, we have to act also against climate change immediately today, because we have the signs. You will see in the next talks. Climate change is not something of the future. It's something that is already impacting our life today, and so we need an immediate action today. The important role of science. This was, you remember on TV, all the discussion, so on and so forth. But science is very important because science gets rid of the fake news. Fake news can swing the opinion of many people towards something that is not true, simply not true. This has happened with the COVID, has happened with climate change. Less and less, fortunately, at least in terms of the climate crisis, but it's very important to rely on scientific evidence and science. Communication is a very important aspect of both crises. To really communicate, I think there were some problems in communicating the COVID emergency. There have been definitely many, many problems in communicating the climate emergency. My colleagues that will talk after me know this very well, and the IPCC is trying to improve it. And then the last point, which I think is very important, it doesn't help to have global negotiations or rules, national and international rules, if the people don't follow those rules, if the people are not engaged. So the personal engagement from all of us in our everyday life is critical to make sure that we can face this crisis. So these are some messages, and I just wanted to end with this slide. Again, I had a lot of time to think during the lockdown, and to me the most incredible thing was that during the lockdown, actually, our society was crashed. People lost jobs, whatever, but the environment was doing great. There was you could see, there was no pollution on the Po Valley. This is something that's never happened in the last 80, 90 years. Actually, Luca knows very well because he lives in Milan, and it was incredible. Over China, there was no pollution. This was really incredible. You could see the fish in the seas of Venice, which never happens. And to me, this is very strange. How is it possible that when we do badly, the planet, which is our house, does well, and vice versa? When we do, quote unquote, well, the planet really suffers. I call this, to me, this is a paradox. I call it a socio-environmental paradox, but you can call it whatever you want. And I think the post-COVID rebirth, or however you want to call it, really gives us a huge opportunity to change things, to restart in a way that is very different, and in which this paradox will not exist anymore. We know that we can do it. There are the technological solutions. It's mostly, I think, a political issue. And the push for this change has to come from the bottom. So I hope that all of us, all the people who are listening to this talk will want to have a different future post-COVID and hopefully post-climate crisis. So I will stop here, Luca, and maybe we'll take questions at the end.
Filippo, I think this is a very impressive presentation, and it suggests many possible meanings to these similarities between COVID pandemic and climate change. You propose to define climate change as an environmental pandemic. This has surely a communication impact, very strong communication impact, because it conveys this idea of urgency of action. But do you think that it can also change in some way the way to face climate change, to modify strategies or to suggest new kind of responses and strategies to climate change as well?
Well, I think... Does it work? Yeah, okay. You know, as I shown in my slide, I think in some way the COVID evolved in much shorter times, but the problems were the same. The problems in terms of how to deal with a global crisis were exactly the same. So I think we can really actually learn from this COVID crisis, because I could have used interchangeably the word climate change or the word COVID, and you could apply exactly the same slide. Just the temporal horizon is different. So, you know, a lot of things that have been done for COVID, or they could have been avoided, like the lockdown, probably we could think in the same way for the future.
Yes.
Try to avoid a climate lockdown by acting early. This is probably what could have avoided a lockdown in the COVID crisis.
Yes. Immediate action is the key message of this presentation. In the meantime, we have already received 3 questions. I think that these questions are for not only for Filippo, but for every speakers. So I will go on and ask this question later, because I would like to introduce the next speaker, Valérie Masson-Delmotte. Hello, Valérie.
Hello.
Hello. Valérie is the co-chair of the Working Group 1. So maybe the first thing to understand is what is the Working Group 1, because not everyone can know what is the object of this working group of IPCC. And I immediately give the floor to you, to your presentation and to your consideration about the new scientific evidence supporting this immediate action on climate change.
Thank you very much. And the Working Group 1 of the IPCC is focused on the diagnosis and the prognosis. How does the climate system work? What are the causes of observed changes? And what are science-based projections for our changing climate system? And to build on what Filippo just showed, climate science highlights how much human activities have led to a global perturbation in terms of atmospheric composition. You can see here over the scale of the last 2,000 years how much the atmospheric composition has changed. You can also see that despite the pandemic and the lockdown, the atmospheric concentration of carbon dioxide continues to increase and will continue to increase. The lockdown led to a sharp but temporary reduction in carbon dioxide emissions. But what makes the concentration in the atmosphere is not just what we are doing now, it's the outcome of accumulated emissions in the past and absorptions by vegetation and by the ocean. And really the key message here is that if you want to reduce the additional greenhouse effect in the atmosphere, it's not about a temporary reduction and back to business as usual. It's about sharp reductions in emissions of carbon dioxide to reach net zero carbon dioxide emissions at the global scale. I also want to echo what was said previously. The pandemic illustrates what we could gain not by crisis management, but by strategic planning. For instance, by decarbonizing transportation, we can reach excellent air quality on the long term, not just temporary because we cannot travel. So there are examples of analogies, but also differences between what is needed at the scale of addressing the climate change challenges. So in a few minutes, not all of you may be familiar with climate change. We add greenhouse gases in the atmosphere, it's changing the composition of the atmosphere, it's trapping heat. And heat is accumulated, it's leading to a warmer atmosphere, warmer soils, it's leading to melting snow and ice at the global scale, and most of the heat is trapped in the ocean, which plays a key role. And because of the inertia of the ocean, this makes climate change already irreversible. We can't go back to the climate we had a few decades ago. And climate science is really focused on understanding how the climate system reacts to perturbations, learning from the past, learning from today's experience, from theory, numerical modeling, to understand how the feedbacks are shaping the response of the climate system and affecting the global climate, but also regional climate characteristics. We are now at about 1 degree of global warming, and that warming is due to past and present human activities. This is a simple representation of many complex studies, and it shows the level of observed global warming with an update until last spring. It shows in blue what would have happened if there had only been natural factors such as solar activity or volcanic eruptions happening. And it shows the dominant influence of human activities in terms of the trend observed at the global surface. And this warmer climate has a number of characteristics. It was already said, a warmer sea and a warmer air leads to more moisture in the atmosphere and can lead to more heavy rainfall events. A direct consequence of a warmer climate is increased frequency, duration, and intensity of heat waves, and all of us have experienced that globally. It's also the case through marine heat waves affecting ocean ecosystems. So climate science is about giving a clear picture of all these characteristics of a changing climate. For instance, how physical changes and chemical changes are taking place in the ocean, which is getting more acidic, losing oxygen, is warmer, and this is of course having cascading effects for ocean ecosystems. On the continents, it's also about understanding how this changing climate affects what drives vegetation production, productivity, how it affects the ability of soils and vegetation to store carbon, how it can lead to changing hazards such as increasing conditions that are facilitating wildfires over continents. So this is really what I try to describe in terms of climate science. It's a long history of understanding the basics of the climate system through physics applied to a complex system, through making sense of precise information on past climate, and through modeling. And of course, modeling is key to explore the range of plausible futures, but it's also now about understanding societal needs and providing salient and actionable climate information, especially at regional scales, that is so important for risk management. And we saw for the pandemic early warning from specialists of zoonosis. I want to flag that in terms of climate change, the early warning was done long ago, since the 1970s. And the first IPCC report, we are now celebrating the 30th anniversary of that first IPCC report. It had the basic understanding. And the current context where science is really key for urgent decision-making shows the value of that collective process. We have now about 40,000 papers in the scientific literature each year with the keyword climate change, looking at all the facets. More than ever, we need that collective effort to analyze what is robust, strongly established, what is emergent but can need confirmation and verification, and also what are the limits of our understanding so that we can inform robust decision-making in the face of uncertainty. And uncertainty is not just about how the climate system works, it's also about how we are going to react, to act, and how fast we are able to take action. So the role of IPCC is really to assess the state of knowledge, the best state of knowledge, and to communicate it as clearly as possible. So this is done through a rigorous, comprehensive, objective, open and transparent basis. And I would like to acknowledge the contributions of thousands of researchers worldwide who contribute to our reports. So a few highlights now on the current cycle. We've released in the past 2 years 3 special reports on global warming of 1.5 degrees Celsius, on the ocean and cryosphere, and on climate change and land. And with my fellow co-chairs, we are going to give different perspectives on these 3 special reports. And I provide a brief status on our main working group reports we are preparing in that pandemic context, so now completely done online. Just to highlight the amount of work underlying each report, for the 1.5 report, it's about 100 authors, half from the developing world, half from developed countries. The assessment of 6,000 peer-reviewed publications, and then several rounds of reviews, which are crucial for the quality of the reports, involving more than 1,000 of reviewers and accounting for more than 40,000 review comments. And just to try to summarize this amount of knowledge, it shows how much each fraction of global warming matters. And on the vertical scale here in the upper graph, you see different warmer worlds today with about 1 degree of global warming, but you can see that for each additional fraction of warming, there's an increase in risks for many natural managed systems and human systems. In other words, planetary health and our own living conditions depend on the scale of global warming. And it's obvious that in terms of limiting risks, limiting the level of global warming is a key priority. The second aspect is that if you want to limit warming to low levels, such as 1.5 degrees, which is really close to today, this would require unprecedented efforts in all sectors, and it would require global greenhouse gas emissions, especially carbon dioxide, to peak as quickly as possible and then decline sharply year after year by about the same amount as the result of the pandemic lockdown, but in a strategic, planned and sustainable way, protecting and everyone and leaving no one behind. By acting very sharply with radical declines in emissions, it could be still possible to limit warming to low levels. It would also require, in the second part of this century, to be able to extract CO2 from the atmosphere and store it durably, which is a challenge that needs to be addressed and which by itself, depending on the options or technologies used, could create more risks for ecosystems or for food security. So the report shows that every year matters, and if you just delay action by, let's say, a decade, then you would have an overshoot above 1.5 degrees Celsius with associated crisis management, risks of irreversible loss for some of the most fragile ecosystems, and escalating risks for the most vulnerable people in societies. But it also implies the same amount of action and more CO2 removal in the future. So very deeply, it's really an ethical question about burden for today's young generations in terms of adapting to a larger change in the climate system, taking more radical action, and exploring more risky options in the future if we don't act now. And this report has a number of novel aspects, working across disciplines, across the usual working groups. And that's what decision makers want. They don't want, a silo approach on one aspect, but having the big picture. There has been progress in better understanding how to express the margin of action that we have, the remaining carbon budgets. I want just to stress that from 1750 to 1990, there was less CO2 emitted in the world than since IPCC reports have been released in 1990. And this shows how much action is needed now. The report also explored storylines of different warmer worlds that will depend on the type of action that is taken. It highlights regional hotspots such as the region around the Mediterranean Sea, which is a hotspot in terms of the severity of changing hazards and potential impacts. It addresses both the transitions in the energy, urban, infrastructure, industry systems, but also the importance of societal transformation, which is in our hands for all of us. And finally, it shows how much each choice matters in terms of feasibility and in terms of sustainability, highlighting the role of science to support technological innovation, social innovation, but also frugal, affordable innovation. And this report has been translated with summaries for teachers or for urban policymakers developed by other bodies, which is really important to disseminate our findings so that they are most available for different users, and education is really critical here. A few remarks about the land report. The key messages from that report is that land is, of course, associated with critical resources for water security, food security, biodiversity, and it's under growing pressure. Sustainable land management is a key part of the solution, but only one part of the solution, and it cannot replace reducing emissions from other sectors, especially those related to the use of fossil fuels. And just to illustrate that, over land, we are affecting 70% of the ice-free surface. Degradation is already touching a quarter of land area. There's a dramatic loss of biodiversity. And there are multiple associated challenges to be addressed by land use. Our food system is unsustainable, and it's really tragic to observe that despite progress in agronomy, in trade, in technology, there are still more than 800 million people undernourished. And this is increasing now at the moment, making food security a growing concern. At the same time, there are 2 billion people who are suffering from obesity or who are overweight, and we see in the pandemic context that this is also a major risk factor in the face of a respiratory disease. And the food system accounts for a third of all greenhouse gas emissions, and it's growingly affected by heat waves, droughts, or floods. Solutions are also available in that sector to act rapidly with multiple benefits. Benefits for planetary health and benefits for human health through, for instance, healthy diets, restoring, strengthening, preserving carbon sinks, so better quality of soils, forests, wetlands, and also the fact that risk management here is particularly important. For instance, fire risk management. Again, I stress the fact that afforestation or the use of land for biomass for energy is part of the solution, but the potential is limited due to side effects that can emerge. And this report looks at the risks, not just in relationship with the level of global warming and regional consequences, but also in relationship to socioeconomic choices, the type of development, the type of society that is being developed. And in terms of food insecurity, so availability, but also access to food, it's clearly the fact that if there's a choice for sustainability in terms of, demography, acting to reduce inequalities, the type of farming systems, the adaptativity of the food system, we can reduce risks to low levels, even for a level of global warming at around 2 degrees. But if the type of development is associated with strong inequalities, consumption, production that is very intensive in resources, with slow technological changes, barriers to trade, barriers to adaptation, then the level of risk for food insecurity becomes really high already for a level of warming of 1.5 degrees Celsius, which could happen in the next decades. On the Ocean and Cryosphere report, what is explored here is the cascading effects between the physical world, ecosystems, and societies that depend on these ecosystems for daily lives, for habitats, for food and security, and also for cultural traditions that are at the heart of societies. And of course, climate change is already affecting these systems from high mountains to the depths of the ocean. And many of these changes will continue for generations to come due to the inertia of the response of glaciers, ice sheets, and ocean dynamics. So this is really the novel dimension, is to bring together information that we have on the multiple aspects of these changes and looking at the response options that can provide multiple benefits for ecosystems and for reducing the severity of climate change impacts and risks. Just a few highlights here. The high mountains are home for more than 6 million people, and 2 billion people depend on water changes linked to the high mountain cryosphere. So our report highlights both the local but also the downstream effects and the importance of integrated response options, for instance, linked to the transformation of tourism or linked to the diversification of activities or to integrated water management along the path of water. Polar regions, they might be remote for you, but changes are extremely high in the Arctic, where the level of warming is 2 to 3 times higher than the global average. And what happens in the polar regions has global relevance, for instance, in terms of how much the thawing of frozen soils will lead to more carbon being emitted to the atmosphere, or through the consequences of the mass loss from the Antarctic and the Greenland ice sheet in terms of global mean sea level rise. And these aspects are still associated with deep uncertainty. So our reports show what we know, but also what we don't know, and where basic research is urgently needed to better understand the scale of global risks. And this report also takes a storyline approach for aspects where the confidence is still limited, but which could be really important in terms of global risks. We don't know under which conditions a radical slowdown of the Atlantic Ocean circulation can happen. There are elements in climate projections. So the storyline approach describes if this mechanism is triggered and takes place, then this is what we know would be the consequences. And thinking of the pandemic, looking at low probability but such high impact events is also important to guide decision-making and risk management. So in terms of polar regions, a clear message is that they will be very deeply different in the future, but that depends on how much greenhouse gas emissions are going to be emitted. And the challenge in terms of adaptation responses regionally and worldwide, it's highlighting the importance of education, of climate literacy. And when we talk about adaptation responses, of course, sea level rise is a major concern for all countries that have major coastlines, such as Italy, but it's a high concern for vital infrastructure everywhere, communication infrastructure, trade infrastructure. And by 2030, it's projected that about 1 billion people will live in these coastal regions. And Hans will provide a clearer view on what can be taken in terms of action to reduce coastal risks. I just want to flag that in terms of climate science, it's really about better understanding the response of the ice sheets. It's also about better understanding the regional characteristics of ocean changes and the interplay with storms that have a key implication for managing risks locally. I'm now moving to the final part of this overview. So the main Working Group 1 report is now underway, and it will address, the changing state of the global climate system, what we understand of the causes and the human influence, but also what we can say in terms of future global climate trends on the near term, but also on the longer term, depending on societal choices. And following that work on the large-scale climate system and linked to it, we'll provide an update on the physical understanding of the mechanisms and processes shaping both the global response, but also the regional response. So the global carbon cycle, the climate forces that affect air quality and the atmospheric composition and affect the climate system, which we call short-lived climate forces in our jargon, but also the global energy budget, the global water cycle changes, and the ocean and cryosphere and sea level rise. And finally, we'll have a strong emphasis on regional information, which is really crucial for managing risks and taking decisions in terms of adaptation. And so how to link global to regional climate changes, a topic for which Filippo Giorgi and others have provided major breakthroughs and which is of key importance. The understanding of extreme events that are so important in terms of the severity of impacts and response options, early warning systems. And finally, how to communicate climate change information that is relevant for regional impact and risk assessment with an interactive atlas of regional climate information that is a novel element of our report. We've received, despite the lockdown and the challenges for all scientists, more than 50,000 comments on our second draft. The authors are writing their final versions of their chapters, accounting for all these critical inputs. And the report will rely on a body of scientific publications, including papers accepted for publication until the end of January next year. And this will feed a summary for policymakers looking at the emergence of human-induced climate change, the current state of the climate system, where are we and how did we get there, the possible climate futures, and what we know in terms of climate characteristics that is relevant for limiting climate change. And this will feed a synthesis report, building on the work of the colleagues from the other working groups, looking at where we are, what are the possible long-term futures linking climate and development, and informing what are the near-term possible responses in a changing climate. And with that, I would just like to finish with this slide showing how much today's choices are key for future risks. So we are now at about 1 degree of global warming here, but depending on the pattern of emissions of greenhouse gases globally, there's unavoidable climate change in the next decades, and it's really critical to know what's going to be there to adapt to it. But after 2050, the scale, the severity of climate change and risks radically depends on choices to be made in terms of greenhouse gas emissions. And that's a clear link to a clear handshake to looking at the risks for these scale of plausible futures, but also looking at the possibilities for action to reduce emissions. So I'll now pass over to my fellow co-chairs from the other working groups.
Thank you. Thank you very much. I would have many questions to ask you, but running time short, and I want just to ask you whether the current models and scenario of this sixth report confirm the scenario and the models of the previous report, or in some way are better, worse, or there are some difference in terms of the projection of the increase of temperatures, of the global warming?
What I can just share is that the approach that we take in this report is not just to report the result of climate models, is to provide a holistic approach, including our understanding of the processes, the feedbacks, the evaluation of the skills of the models. So what we are going to report is the outcome of our assessment of confidence in projections. That's really a novel aspect compared to the past work. And also, as illustrated in the design of the report, a strong emphasis on regional information, building on multiple lines of evidence as well. So I can't answer precisely to your question because it would be unveiling the conclusions of the report that is underway. I just want to flag that many features of the past reports have been strengthened by novel knowledge.
Okay, thank you very much. So now I want to give the floor to Hans-Otto Pörtner, co-chair of the second working group. Here the issue are the vulnerability, the risks, the impacts of climate change. This is a very important point, and so please have the floor.
Yeah, thank you very much. I hope you can all hear me.
Yes.
Thank you. Yes, and I will build on what Valérie said, and Valérie has already touched on some of this with respect to the analysis of the impacts of climate change, the risks, and certainly the consideration of that we need to minimize those impacts and their severity is guiding the ambition in mitigation and adaptation. So working group 2 goes from impacts and risk assessment to also addressing that part of the solution space, as we call it, talking about the adaptation under climate change, and working group 3 is then looking at mitigation. Just to briefly summarize, we have seen some climate changes, and we've already heard that. We are seeing consequences for people, nature, and livelihoods. And on the trajectory that we currently are, we are expecting to reach the famous 1.5 degrees quite soon, between 2030 and 52. And this is a result and has been a result of the 1.5 report. Past emissions alone do not commit the world to 1.5, so we have a choice to make. And the question really is, do we understand the urgency? And the urgency comes from the impacts and the growing risks, but also it comes from the limited time that we still have to cut emissions to a degree that we do not go beyond the 1.5. That is at least the ambition or part of the ambition of the Paris Agreement. Now, this 1.5 degrees as a global mean temperature is distinguishes between ocean and ocean surface and land temperatures, and we must certainly consider that over land we have already reached those 1.5 degrees. And land is a critical resource. We rely on it for food, water, health, and well-being, but it is under human pressure. And the oceans are already under human pressure, as we've heard from Valérie. These pressures may have led Filippo in his talk to talk about society being out of sync with the planet. Human activities are a burden to the natural systems of the planet, and we need to reach an equilibrium, a balance that allows these systems to thrive and also to support the well-being of humankind. Just as an example, over land we see desertification and land degradation, and part of this is due to human activities. Drylands cover about 46% of the global land, and 3 billion people are living there, and the population is growing. But at the same time, the annual drought for drylands is growing. And this clearly reflects the current background. We have unsustainable uses of land, and now we cause the climate system to change, and this is certainly exacerbating the situation. And our working group is actually the one that does these risk assessments, uses these burning ember diagrams, where we talk about how the risk develops from undetectable to moderate to high to very high, and looking at very well-defined criteria that define these risk levels for every system that we are looking at. And this, we use a color code for this, going from white to yellow to high, to very high, from white to yellow to red to purple. So as you can see here, we have been looking for the land at dryland water scarcity, soil erosion, vegetation loss, wildfire damage, permafrost degradation, tropical crop yield decline, and food supply instabilities. And you also see the sort of temperatures discussed in the Paris Agreement, sort of the 2 degrees versus the 1.5 degrees. And this is the kind of comparison we did and started with in the 1.5 report. And these comparisons are going on and also taking place in the main assessment reports that are currently under preparation. And you see for many systems, we would stay in the yellow arena with the 1.5. But for some of them, like wildfire damage, permafrost degradation, tropical crop decline, and food supply instabilities, with 1.5, we are also already touching the transition between the yellow and the red color code. So there are challenges ahead as a result of climate change that add to the burdening of our planet by multiple human activities. Human food security is at stake. And it's not only that. We also have to consider that with the degree of climate change, and here looking at temperature, mean global temperature as a measure, we also have the issue that human life is at stake. Humans, just like every life on the planet, is specializing on a limited degree of temperature. The planet offers us a temperature range where we can live, natural systems can exist, and where we can build a sustainable life, but pushing us outside of this climate envelope is coming with risks. And we are already experiencing these risks as indicated by the extended transition from yellow to red between the 1.5 and 2 degrees global mean temperature, exemplified by the mortalities, human mortalities experienced at all latitudes with extreme events and also with heat waves. And Europe by itself has been exposed to heat waves with loss of human lives on each individual case. Moving from the land into the ocean, we've already heard about this. This is actually the largest scale system on the planet. And combining ocean and cryosphere, we have in the special report on those systems actually covered 80% of the Earth system, looked at their interdependencies, at their role in terms of life sustaining and support, life support functioning for ecosystems and for humans from the top of the mountains to the depths of the oceans. These systems are experiencing changes. Ocean heat is rising. Ocean pH is dropping as a result of ocean acidification and CO2 uptake. Ocean oxygen is declining because the oceans are stratifying, and the oxygen, the air-gas exchange with the air is decreasing. We have marine heat waves that have an impact on ocean life, and we also have, due to the melting of the ice of glaciers and the ice shelves, we have rising sea level, we have permafrost temperature rising, causing the additional challenges of the release of greenhouse gases from those places. So this is really a systems view of how these processes that are so much intertwined are actually and can then also feedback on to the limit system. But in terms of background, we have to make the same statement as for land. The current background is that we currently see unsustainable ocean uses, and we need to abandon that phase of human history. Let's talk a bit about sea level and the extreme events that are ahead of us and that are already developing. And a good measure for the extreme sea level events that may happen is the so-called historical centennial extreme sea level, which has happened once per century traditionally, but may then in the future may happen for more frequently, up to 1 per year. And this analysis actually, and the colored dots here indicate where in the different places actually these extreme events may go out of phase, out of the traditional, and where actually already early during the century, we are seeing sea level that has never been experienced in these places over recent history, at least over human history, and how this is actually challenging the coastline. Let's talk about risk assessment here in this context as well. And we have been comparing risk assessments for these different places along coastlines, talking about resource-rich coastal cities, large tropical agricultural deltas, Arctic communities, and urban atoll islands. And you see, again, the color code, how it develops depending on the emission scenario, whether we go for high unabated emissions at the high end, the RCP 8.5 scenario, or whether we will be able to control emissions and keep to the RCP 2.6 as a low emission scenarios with a median close to 1.5. And you see how adaptation can make a difference. The left-hand side shows the sort of low or no adaptation situation, which is the current situation. And then on the right-hand side in the columns, you see how risks develop with high adaptation activities. And you see how the risk thresholds are actually coming down without adaptation or going up with adaptation. But it is very clear that there are adaptation limits in places. And this is an ongoing area of research for many, many systems where we don't have a full understanding of those adaptation limits. What we can say for human societies, actually, that there is a difference between whether people will be able to adapt in situ, stay where they are, and compensate for the increasing sea level, or whether they have to leave those places and go into what we called planned relocation. And you see that the high-risk places like Arctic communities or urban atoll islands, as they reach adaptation limits, have no other choice but abandoning the area. Let's look at ocean life, marine life here, and the ecosystems, the diverse ecosystems there. And you see again in relation to these enigmatic temperatures, 1.5 and 2, how the risk transitions are to be found. And there's one important system, the warm water corals, the fringing ecosystems along many of the low latitude coasts are already in a high risk situation and will be moving into a very high risk situation as temperatures climb up. Other systems will remain in the yellow area. So giving us a news, yes, there is one system under big challenges and that's bad, but there are other systems where we can keep the impacts still under control if we go into ambitious emissions reduction. And how does that one very vulnerable system look? You're seeing a healthy reef on the left, one that has seen extreme temperatures, seen a marine heat wave in the center, and one that has bleached. It has been losing its power plants, the algae that provide the system with energy. And if this is taken too long, the system is completely converting into one with low biodiversity on the right-hand side, overgrown with algae, and it's a dead reef, essentially, very minimal activity there. This kind of heat effects also concerns our fisheries resources. As you see here, we have a certain tradition of having fisheries catch potential in those areas. This catch potential is shifting with all life, shifting to higher latitudes as the planet warms, and especially in the low latitude, we see a large decline in the fisheries results. We will see that even in a 1.5 degree warmer world, and even more so in a world undergoing unabated warming. So there's something to be said about the temperatures to be reached and to be controlled in the future in order to control the impact and risk. We should certainly try and avoid going beyond 1.5. We should also try and avoid going into an overshoot, because an overshoot that may actually in the end take us to 1.5 by end of century will cause over decades the same impacts and risks as if temperature would stay at that higher level. So ambitious mitigation and adaptation and avoiding overshoot might be a good guideline for humankind and would be a good guideline for humankind into the future. And we have nailed down these numbers, sort of the minimum efforts in a way that need to be made in terms of taking us and keeping us to 1.5. CO2 emissions have to fall by about 40% by 2030 compared to 2010. For Europe, that certainly means, with a milepost of 1990, more like a 60-65% reduction compared to 1990. CO2 emissions would need to reach net zero around 2050. And we would also not only look at CO2, but also look at non-CO2 emissions like methane, nitrous oxides, and reducing those emissions would also contribute and have direct and immediate health benefits. With 1.5 degrees, we would have it easier to reach the Sustainable Development Goals. There are multiple synergies between mitigation and adaptation technologies that could be placed here in order to reach those targets. But, surprise, the COVID pandemic has kind of taken us away to be so focused on climate change and what we should do about it. But there are some issues to be said here, that actually the COVID crisis and the perspective of future pandemics, also resulting from human activities on the planet, and climate are intertwined. We are currently seeing serious diseases and passing from animals to humans. In history, the names to be called out are Ebola, HIV, SARS, and now COVID-19. And clearly the exploitation of wildlife and loss of wildlife habitat quality have increased opportunities for these disease spillovers to human. Recent publications indicate that actually once humans change an ecosystem and adapt it to their needs, the wildlife remaining has a greater proportion of local species and total abundances of hosts of human shared pathogens in sites under substantial human uses. Secondary ecosystems, agricultural systems, urban ecosystems, all are to be named here. And climate change again comes on top of this because climate change causes shifting animal distribution, mixing of ecosystems, mixing of abundances, causing new encounters. So there is a complex interaction between all of these aspects that has to be taken into account in future management. And we need a combined management of land and ocean for conservation, for restoration and sustainability, combined with ambitious mitigation. This will support biodiversity conservation, it will support high food security for humankind, it will support climate mitigation, and it will avoid future pandemics. So these things are all intertwined, and calling this message out very loudly and clearly should provide guidance to our policymakers in terms of the decisions to be made. Our Working Group 2 report will dive into this, it will look into this, and we have a storyline that we call the FAO 2020 narrative that we have developed in order to reach out, to build a coherent set of messages for the policymakers to consider. Starting and looking at the societal context of risks, doing what we conventionally do, look at projected impacts and risks under future scenarios, considering how adaptation limits and adaptation progress is important in the context of reducing risks and the risks development over time, and emphasizing the solution options more, the adaptation complexities, the costs, the benefits and finance associated. Looking at the interface with Working Group 3 in terms of what they say about mitigation efforts, talking about decision systems, governance systems, and finally, trying to develop a vision for climate resilient development. The system transitions involved, sustainable development involved, the feasibility and the financing. And all of this will be coming out as a second of the main reports in 2022, early 22. That is our current deadline. And with that, I thank you for your attention and hand over to Jim Skea as a representative of Working Group 3. Thank you.
Your presentation about risk, but I want to ask you just one question about among all these risks you mentioned, which is, in your opinion, the most threatening one for human being? Just if you have to rank them, which one you choose among all these risks, rise sea levels, food insecurity, which is the most incumbent, more threatening?
It is certainly very difficult to rank those risks, but I think what we can say is that if we destabilize the climate so much that we surpass the tipping points of the climate system, that in a way the climate changes get out of hand, that humankind can no longer push back and bring the climate into a stable situation. Those, I think, would be the biggest challenge ahead, and we are well advised to keep below that threshold temperature. Unfortunately, we don't know that temperature very well, but we certainly see the exacerbating risks for all these different systems. We see those risks early affected, like the coral reef system, a global system, where we will already and almost certainly lose about 70 to 90% of it, should be a warning not to fiddle and to allow climate change go on any further than agreed in the Paris Agreement.
Thank you. Thank you. Okay, let's pass to the last speaker, James Ferguson Skea, that is a co-chair of Working Group 3, to have maybe some good news or some focus on solutions and so on responses to this grim landscape of risks and impacts. So
okay,
please.
Thanks, Luca, and thanks for the challenge about being optimistic, which I'm always ready to rise for. So Working Group 3 is essentially about climate change mitigation, which, to summarize, is essentially about reducing emissions of greenhouse gases, but increasingly also about how we take carbon dioxide from the atmosphere. And I'm aware of the time constraints we're under, so I will go through this quite quickly. But my talk has three parts: what we've learned about mitigation from the special reports, perhaps a bit more on what we're working on now for the full sixth assessment report, and just one slide that has some reflections about cross-working group collaboration and the COVID-19 context. So first of all, the report on global warming of 1.5 degrees, both Valérie and Hans have mentioned this, and both have mentioned that, broadly speaking, to keep global warming below 1.5 degrees, we need to reduce carbon dioxide emissions by roughly 45% by 2030. But this is one slide or one figure that's absolutely key for the mitigation element of the 1.5 report, which shows that we have some choices about the means by which you could keep global warming below 1.5 degrees. Our authors found about 90 scenarios in the literature that were compatible with 1.5 degrees warming, but they varied a bit in terms of how they actually got there. And what this slide shows us, the solid blue line is net carbon dioxide emissions. That's emissions minus removals from the atmosphere. The grey part is emissions from fossil fuels. The orange part, emissions or sinks from agriculture, forestry, and land use. And the yellow part is removals from a speculative technology, bioenergy with carbon capture and storage, which works to remove carbon dioxide from the atmosphere by growing crops, burning them in power stations elsewhere, capturing the carbon dioxide and burying it in geological formations. And the net effect of that technology is to take emissions from the atmosphere. Now, very clearly, in all of these scenarios, emissions from fossil fuels have to drop, in some cases very rapidly. Just to say what that involves, we use the phrase rapid, far-reaching and unprecedented changes in all systems. So examples there: renewable energy would need to dominate electricity by 2050, up to about 85% of electricity globally coming from renewables. Coal would be pretty much eliminated from the global energy system by 2050, although oil and gas would persist longer. In fact, in one or two scenarios, gas use actually rises by 2050. But we need deep emission cuts in transport, buildings, urban systems and infrastructure. Basically, nothing can be left off the table if we want to keep global warming below 1.5 degrees. But what this slide shows is the kind of trade-off that you have. At one end, at the left-hand side, with pathway 1, you can start reducing fossil fuel emissions very quickly, and that could eliminate the need for technologies like bioenergy with carbon capture and storage during the 21st century. On the other hand, pathway 4, on the right-hand side, there's a delay to reducing fossil fuel emissions. And the only way then in which you can keep global warming below 1.5 degrees is to deploy large amounts of negative emission technologies. And I know that this troubles my colleague Hans Pörtner greatly because of the implications for food security and biodiversity, which I'll be getting onto. But just to say that every pathway that keeps warming below 1.5 has some form of carbon dioxide removal in it. And most, but not absolutely all scenarios use some kind of bioenergy with carbon capture and storage. And basically, these negative emission technologies all relate in some way to the way that we use land. Which brings me on to the land report very quickly and some of the conclusions that were reached on response options there. Now, Luca, this is the optimistic part of it. We did look at 28 different response options that involved limited or no competition for land. In other words, they were about how you used better the land in the way that we're using it already. It didn't really involve big changes in land use. So these kind of response options covered agriculture, forest management, soil management, and management of other ecosystems like wetlands. It also included response options related to demand, for example, reducing post-harvest food losses or dietary changes. And in each case, we looked at these options. Did they contribute to mitigation? Did they contribute to adaptation? Did they help deal with desertification and land degradation? And what was their impact on food security? And basically, I'm not going to go through this slide in detail, but blue is good and orange is bad. And basically, the message is that almost all of these options had positive impacts in terms of mitigation, adaptation, and these other things that we were thinking about. So Luca, that's an optimistic picture for these options. And some of these options are not represented in the models that were represented in one of the previous slides. Now, there's a but about that, because we also identified 4 broad types of response options, which involved big changes in land use that created much bigger challenges. And these related to afforestation, reforestation, the use of biochar, and then bioenergy with carbon capture and storage. And here, there were the potential for large negative impacts in relation to food security and biodiversity. For example, if the techniques were deployed in the wrong kind of way. It's worthwhile emphasizing that we are not saying that bioenergy and BECCS is bad. It absolutely depends on the scale at which it's deployed, the type of crops, the type of land that is converted, and the kind of management systems that are put in place. So the way that these techniques are deployed is absolutely critical, but there are certainly risks if they are deployed in careless kinds of ways. So I hope that is summed up. Because my colleagues have talked a lot about the existing reports, I won't take this any further, but I think it gives a highlight for some of the challenges that we face. There are big possibilities, but also risks if we don't handle it properly. Now, I'm going to turn to the full 6th assessment report in Working Group 3 in mitigation. And right at the start of it, myself and my fellow co-chair, Professor Shukla from India, set out 3 ambitions that we saw it for the 6th assessment cycle that built on previous efforts. One is that we didn't just want to look at large-scale global emission scenarios. We wanted to think very specifically about the practical steps that we need to take in the short to medium term to make realization of things like the Paris goals possible. We also wanted to address what we saw was a gap in perhaps previous IPCC reports on what you might call the human dimensions. So we wanted to address issues around lifestyle, behavior, and consumption by making greater use of social science disciplines, not just economics. And finally, we wanted to link climate change mitigation to other agreed policy goals, particularly in relation to sustainable development and the UN Sustainable Development Goals. So these ambitions were very much what we set out right when we scoped out the report. This is the report structure we have, 17 chapters. I'm not going to go through them in detail in this slide, but I'm going to argue that they do indeed reflect the ambitions that we set out. So the sustainable development context, we have two, what you might call bookends chapters that open and close the report. Chapter 1, in which we set out conceptually the way that mitigation and sustainable development are related, and chapter 17, where we draw together the threads from the intervening chapters to think about how mitigation and a transition to a net zero world can be achieved in the context of sustainable development. We do have a set of chapters that do take this global helicopter view of the world, a chapter 2 on current trends and drivers, and that will include a little the impacts of COVID on emissions. We have a chapter on long-term emission mitigation pathways out to the year 2100, which has been there in previous reports and has very strong linkages with Working Group 1. But we've added for the first time a chapter on mitigation and development pathways in the near to mid-term, by which we mean 2030 to 2050. And the relationship between these two chapters is critical. And finally, just to say, since previous IPCC reports on the modelling has been criticised for lack of transparency, we have introduced an annex on scenarios and modelling methods that we hope starts to open the black box on the techniques that are used. The meat of the report, if I can put it that way, is the sectoral chapters that look at particular areas: energy, AFLU, urban systems, buildings, transport and industry. And we've given a much higher priority to urban systems because cities was deemed to be quite a big focus for the 6th assessment report. And we do have a cross-sectoral chapter that starts to look at in more depth at some of the carbon dioxide removal issues that don't readily fit into a sectoral definition. We have a set of chapters on enablers, basically things like policy making at different levels, the money factor, investment and finance and the role at which play, and science and innovation. We have for the first time in IPCC a specific chapter on innovation, technology, development and transfer. So this is very much part of the overall picture. And the one chapter I have missed out is again a completely new chapter for IPCC on demand, services and social aspects of mitigation, which is drawing on a very wide range of disciplines. And just also to be optimistic, I can say that IPCC authors are people too. This is a picture of the entire Working Group 3 team in Edinburgh at their first lead authors meeting. And if you look closely, I think you will see a smile on every face. So Luca, we are optimistic about the future. Now, one thing, as Valérie said earlier, we've gone into virtual format with lockdown, and IPCC Working Group 3's third lead authors meeting took in place entirely in a virtual format. And I want to just say that one of the things that we emphasized at that meeting was not just work on the individual chapters, but the linkages across the chapters and also links to the other working groups, which I'll be getting on to. So we had a set of breakout groups on the left-hand side, which we've had in every previous IPCC report. They're very much our standard fare, but we also had some novel breakout groups addressing new topics as well. I won't do them all, but just to pick out just transition. One thing that's of great concern because of the very rapid transitions that are implied by net zero by mid-century is the question of fairness and the impacts on different parts of society, and particularly the implications on employment for people in high carbon industries. So we've had a just transition theme running, talking about how some of these social aspects can be managed through a transition. And just to say, this links to COVID, since the COVID-19 crisis has exacerbated inequalities, this becomes even more important. We had a breakout group on digitalization, and this touches many, many chapters, including how you handle variable renewable energy in energy systems, but also big social change as well. And for example, it is very difficult to imagine how we would have got through the COVID crisis in the way we have without the ability for digitalization, remote access, and virtual activities. We have a breakout group on feasibility. And in the 1.5 report, authors looked at the feasibility of individual response options. The novelty that we are working on at the moment is that we're looking at the feasibility of system change overall, basically trying to get to the question that media people often asked, is 1.5 degrees still possible? And finally, we have had a breakout group on COVID-19 itself and how a slowly emerging literature could actually be built into the Working Group 3 report. And just to say, a big emphasis there, we will of course look at the impact on emissions during 2020, but what the bigger part of it will be on how the economic recovery can be linked to climate change mitigation and investment in a zero carbon future. And that, I think, will be the bigger part of the picture. And in fact, it's our investment and finance people that have been leading that breakout group. Now, but this is my very last slide. So just, I wanted to say something. You've probably picked up that although Hans, Valérie and I are in different places, you may have detected a good chemistry. We work very well together across the working groups in this cycle. And one reason is that the special reports, which are all cross-working group collaborations, have made this collaboration essential. But I also want to emphasize that the working group co-chairs and our bureaus also wanted it to happen, and we've tried to drive it. And some of the consequences are, for the first time, a common glossary across all of the working groups so that we don't have different definitions of net zero and carbon budgets, for example. And there have been some very productive discussions between authors from different working groups so that we arrive at a common understanding. Greater interaction between research communities, and this has been of a great help. For example, it was only during the 1.5 report that the issue about the difference between different metrics for global temperature really started to come through. The virtual operation caused by COVID-19 has really opened up new opportunities for us, as well as causing difficulties, which I wouldn't underestimate. So we have had unprecedented degrees of participation across different working groups in our virtual meetings. And this has been incredibly productive in working towards a common approach across the whole cycle. And just finally to say, of course, COVID-19 has caused inevitable delays to the cycle. And I think only Working Group 1 is likely to be completed before COP26 for the Framework Convention at the end of next year. But we are all working towards fitting into the global stocktake in 2023. And if I could be permitted one last word, Luca, and it's in response to what Filippo said right at the start about analogies between the pandemic and climate change. I just wanted as a final soundbite to give one difference, that there is no vaccine against climate change. It's entirely a preventative activity. It's cumulative, it's chronic, and we cannot go back if and correct the mistakes we've made in the past. So I will finish with that soundbite, Filippo. Bang on 12:30, I hope.
Thank you, Jim, for your presentation. Very interesting to this landscape of solutions and of measures that we can implement in the coming years. You stressed at the end of your presentation the problem of to tackle also with the lifestyle changes and policy goals and so on. And I received just a certain number of questions about lifestyle changes. For instance, these questions, I would like to hear someone speak about the impact of animal agriculture for the production of animal protein on climate change. Why are the images just references cars and industrial complexes? we have a very powerful tool to reverse this trend, our diet. Do you think that diet is one of the key solutions for climate change?
Yeah, just to say, Luca, this was one of the key conclusions, I think, from the Special Report on Climate Change and Land, because it looked at the demand side and it looked at the food system as a whole. And it is absolutely the case that if people were to change their diets in ways that reflect health guidelines, if they did it in their own interests, it would bring amazing benefits in terms of reducing the impacts on the climate. One thing that we need to be quite cautious about, I think there's a resistance to scientists telling people what to eat. And I've had a number of radio program interviews where that becomes an issue. So we need to phrase it very carefully. And I think linking it to the health issue is really helpful. But it's absolutely right. It could be a big part of the solution.
Thank you. Just in time, because time is over, but if I 1 minute, I want to ask Filippo, since we have started with COVID and finished with COVID, I want to give to you the last word for a comment, what you said in this, what you heard in this session. If you have some comment.
Actually, it looks like it's going to blow up anytime.
Time is up.
So I'll be very brief. Just two messages I would like to give that I think I heard everybody, all of the speakers actually say. One is the urgency. People now, everybody talks about COVID, about other problems, about economic problems. This is, of course, very legitimate. But let's not forget that the climate crisis is not over. It's worse than ever from what is happening recently. And if we really want to be effective in avoiding drastic measures later, we need to implement all that has been talked about in this session, starting today, tomorrow, or even yesterday. So that's the first message. The second message I would like to take from Jim, actually. He showed this nice picture about people. When we talk about climate change, we don't talk about an abstract planet that may live or die or whatever, but we talk about us. Because the planet is going to survive 5 degrees of climate change. In the past, Valérie knows very well, the climate has been much warmer than today. There were dinosaurs, there were all sorts of, biosphere, so the climate will survive 5 degrees global warming. It will survive melting of the ice glaciers, of the Greenland ice sheet or whatever. What may not survive is society as we know it. 7 meters of sea level rise if the Greenland ice sheet melts means that a good portion of Italy will not exist. So the planet will survive, but would we like that? So we are really not talking about an abstract planet. We are talking about us. And so everything we do about the climate change crisis is really to save society and to improve the well-being of people. So we should really never forget that. So these are my 2 pennies.
Thank you. Thank you, Filippo, and thank to all of you for your participation to this session and to the public. I apologize, I couldn't ask all the questions I received virtually and maybe also by the audience, but next time we will I hope there is another opportunity to go through all this process, to understand this a huge amount of things that you have just started to mention. So thank you very much to all, and thank you. Bye-bye. Bye. Thank you.